Hi everyone, this is Nafish. Today we are going to go over autonomous vehicle and I will try to give you a very basic idea of what is an autonomous vehicle is and what stage we are currently at of autonomy. Okay, so let's get started. First of all, let's define the autonomous vehicle. Okay, so in my words, a vehicle that can take you from one place to another place without any human assistance or decision making, we can call that vehicle uh, autonomous vehicle. Okay, so basically the vehicle will take its own decision and do the maneuver. Okay, so what are the benefits of having an autonomous vehicle? Okay, so I mentioned few, there are a lot. Okay, first of all, road safety. So uh, the accident number of accident will be reduced. Then personal freedom. So personal freedom is like, a blind man can get into the vehicle, a handicapped man can get into the vehicle and go to the final destination, right? Or for example, you have a group of friends and you want to talk and play some games while in the vehicle, and no don't want need to worry about driving the vehicle, then the autonomous vehicle will give you that luxury, right? Then it's going to be cost effective. So why it's going to be cost effective? Because the vehicles can talk to the other vehicles, they can predetermine the routes and and take you to the best possible way to the final destination. So it's going to be fuel efficient and also going to be cost efficient in a sense, because there will be lesser accidents, so lesser insurance involvement, right? And the final one is the less gridlock. So basically, traffic jam will be reduced, okay? Because the decision making will be done by the vehicles, and they can also pass the information to the other vehicles, like which road they are following, okay? And what are the conditions of that road. This kind of information, it will be interchanged, okay? So that's why in future we expect lesser gridlocks, okay? So right now, we are not in full autonomy, okay? So the definition I provided, that is for the autonomous vehicle, which we aim to have in right here 2030, okay? Level 5 full autonomous, okay? Right now we are somewhere between level 3 and level 4, okay? So we have defined the autonomous or autonomy of vehicle in 5 levels, okay? So we started at level 1, level 2, level 3. So these 3 levels we can say driver assistance. So basically the vehicle will not take any decision by itself, but it will pass its observations, warnings, or any information to the driver, okay? So but the driver will take its final decision, okay? So but level 4 and level 5 are pretty much autonomy. Level 4 is just the highway thing, but and also the driver needs to be involved. Level 5 is, there is no involvement of the driver. So this is how we have defined the roadmap or goals for the autonomy, okay? And right now I think we are at somewhere in between level 3 and level 4, okay? So let's move on to the next slide. Here are some of the features, okay? So some of the driver assistance feature, or some of the names of the feature we kind of hear every single day, even from not non-technical people, okay? So some of those I have mentioned here. One is the ACC, adaptive cruise control, okay? So basically ACC is like the vehicle will increase its speed or decrease its speed based on if there is a vehicle in front of you. So basically you get into the vehicle and you set up a cruise speed, right? So and you take off your foot from the accelerator and the vehicle is just going by itself. But how about if there is a car in front of you, okay? Then you have to press the brake, right? But in case of ACC, it will just reduce the speed a bit when the car is in front of you, and if the car goes away from you, it will just get back to the set speed. So this is how the adaptive cruise control work. Similarly, we have AEB, that's the emergency braking. In this case, this works in a very short range kind of scenarios. And if something just comes in front of your bumper, some vehicle suddenly breaks out, or some pedestrian, some biker, then there will be some AEB involvement, so it will just brake immediately and mitigate the impact of the collision. Okay. And there are two other things which is highly used in today's world, that is lane centering and lane change warning. Okay, so lane centering is like, sometimes we talk on the phone, and we are just crossing over these lines of the lane, and basically there will be a push from the steering wheel to put you in the center of the lane. Okay, so basically this is how this centering works. And warning is like you are changing the lane, and if there is a vehicle in the next lane, in your blind spot or somewhere close to you, it will just give you some warning. Okay, so there are lots of other features, but these are the four I think I guess, like, kind of mostly we have in most of today's vehicle, on current generation vehicle. Okay, so next move on to the next slides. So here in this slide, I got it from the CSS UMIC, and basically here in this slide it's kind of pretty much detailed picture of the sensors we have in the autonomous vehicle. Okay, so let me go over that. So radars are kind of mounted in the front fascia right there. Okay, this is the radar, and then you have infrared sensors. Okay, okay, and then usually the camera is mounted behind the windshield. Okay, and all these sensors are kind of the way it is mounted or blended into the vehicle, it's kind of very hard to find out from normal people like us. Okay, so this is the camera, this is the radar, this is the infrareds, and then we have the lidar on top of the vehicle. So LiDAR is required for fully autonomous vehicle. We don't see the LiDAR in most cars, but it might be in the future. Okay. Then you have GPS. We all know about GPS. We have ultrasonic sensors. So ultrasonic sensors are needed in short distances, to give some warnings. Sometimes we hear the beep right from the car when backing up or going forward to a some object. That's from the ultrasonics. Okay, then also the pre-built map, because sometimes we do not have the GPS available in some coverage in some places. uh, and lastly, two things, that the V2V. So remember I told about vehicle to vehicle communication. So the smart vehicles or the future vehicles will be able to communicate with each other. And also the INS. INS is something uses like the other sensors as well, like the radar, camera, and lidar, because this provides the vehicle at what speed your car is moving, and what is the yaw rate, like what speed you are turning, what is the angle of the turn. All this information, this kind of provided by the INS. Okay, so let's move into the next slide. And here I'm talking about some key sensors for object detections. Okay, so basically these four are the sensors which gives you the idea of the environment. Environments like if there is any object in front of you or on the side or behind. Okay, one is the ultrasonics. This is for the very short range. Okay, so if you are just close to a car, and like you are crossing and this car wants to back up, it will just give you warning because there is a person behind. Okay, so ultrasonic works at the very close range. It's very low cost, but it got some downside as well, as you can see. Okay, um, camera, radar, and lidar, these three all these three try to provide range and speed information of an object. Okay, so if there is a car from you, like at certain distance and certain velocity, all these sensors try to provide the same information. Now there will be a question like why we are using all three, not one, because each of these sensors got some plus and minus. Okay, for camera, you know just taking an example, camera, it's low cost. Okay, costing is a huge impact, has a huge impact of the autonomous vehicle. okay, because you just don't want to pay like too much money for these features, right? So camera is low cost. On the other end, lidar is very high cost, cause you have a moving lidar just moves and emits um, lights, right? So basically it got a moving part, it's bulky, it got a lot of solid state, and it's expensive. On the other hand, camera, it just it can provide you like only 2D information, but lidar can provide you 3D information. Now, what is the benefit of the radar? Radar has a very good chance of picking up a moving object at a certain distance, certain velocity, in even if the weather is not good. Because like camera and lidar, the weather has some impact on this. But the radar, it can see in the snow, in the rain, in the adverse weather condition, and also the range information and the velocity information is very accurate from the radar. On the other hand, the radar cannot classify an object. So we have lot of reflections, right, from the road, but which one are the object of interest, right? That classification is not coming from the radar. That comes from the camera or the lidar. So camera is like, it can classify an object. So if there is a human in front of the car, it can say, oh, okay, this detection is coming from the human, not from the some tree or some other things, okay? Or it can just give you the color information as well. So basically the traffic light or like the stop sign, they all got some colors, right? And the camera can decode that. The radar and the lidar, they cannot. Okay, so all these sensors, we use for object detections, and they have their pros and cons. This is like, some has like upper hand in some certain condition, and the some other sensors, they just work really good in bad weather. Okay, so next move on to the next slide. Here uh, we're talking about how this object detection or the fusion works in a vehicle, like how the vehicle comes to a final conclusion, um, and if there is a threat object in front of you or back of you, and lets the driver know. So here I try to um, get some information from the radar, camera, and the lidar. Okay, so remember I just told like all these three sensors try to provide you range information, like how far an object from you, and the velocity information. Okay, and also try to classify the object. So these are the information we're getting from these sensors from the environment. Okay, now the first step will be the filtering the data. So whatever return or objects we are getting from these sensors, some of the returns, they are not relevant to our path. So we are moving at a certain direction, right, at a certain speed, and we are focused at a certain path. Okay, and some of the objects will not be of our interest, and we just need to filter those objects out. Okay, and then we will do a sensor fusion, meaning we will take the outputs of all these three sensors, and we will try to merge these outputs together and have a single output from this sensor fusion. So that both of these three sensors, let's say saying that there is a car in front of you which is at a certain range. Okay, so we'll just combine these three information and output as a sensor fusion data. There will be a lot of correction, a lot of waiting on that. I'm not just going into that, but this is the step. And then from the fusion, you will create a track. Okay, track is the one, like, you are just keeping an eye on. So basically tracking object while driving is like objects that can cause you harm, or like you can collide with those sort of object will be, there will be a list of those objects. Okay, and those we call track, and at every second we'll update those tracks, meaning like the distance and the angle, all these things, this will be updated. So from the tracks, basically we calculate the threat object, okay, and time to collision. So um, at what time these two cars can collide, what distance they are at right now, like basically a list of objects which can cause threat, okay, and those objects, the priority will be determined based on the time to collision, okay. And finally or lastly is alerting the driver. So there will be a threshold, right? Okay, so every person or human, they have a reaction time, and we that's the threshold, okay. For example, you have a reaction time, and that is the threshold. So if the time to collision is going above the threshold, it's going to alert the driver and say like, hey, there is something um, in front of you, and be careful, it can cause an accident, and press brake, or like go to the next lane, something like that. So I think this is all from for today. Just trying to give you guys an overall idea. This subject is massive, this is huge, but hopefully I pass some valuable information. Take care.